to think of it in terms of car lengths, because a lot of times it's hard for people to wrap their heads around how many standard deviations away. But you kind of think of it as how many car lengths away, because you guys have all dealt with staying 3 car lengths away from the car in front of you. So think of it as, each standard deviation is like a car, and how many car lengths it is. So this is 1.72 car lengths away from the mean. And every problem, of course, will have a different car length, a different standard deviation. Okay, so your quiz problem number 5 was this one here. If you did not write it down now. As Z-score represents the number of standard deviations. You can make it SD if you want, S dot D. A value is above or below the mean. So everybody write down. Okay. What's the likelihood this will be on the exam?
100%.
Why is it on the exam? Because it's really important. You need to wrap your head around the idea of what a z-score is and what it stands for. Okay, now, finding the Q1, Q2, and Q3. So first of all, you need to put your data in order. On the exam, when I ask you to find the 5-number summary, the Q1, Q3, you will not be able to use your TI-84 calculators. You will only be able to use a basic calculator that does basic stuff. So I think a TI-30 and below would work. I'll have to kind of check them as they go, but basically a simple basic calculator only. So you can't use a calculator to do that, and that's a good thing because you'll get it wrong every time if you use your TI-84, because the way we do it is not the same way, right? It's like the percentiles. You're talking about typically applying them to thousands of pieces of data, and we're only going to apply them to like 10 or less just to save you time. All right, so first, put your data perfectly in order from smallest to largest. Then it says, find the median of the data values. That's the value for Q2. If you average 2 values, say if you have 1 value in the median, then there's just 1. But if you have 2 values tied for the middle, you average those 2. Neither of them is the median. Does everybody understand what I'm saying? The median is sort of between them. It's the value between them that you've averaged. So they're not included in the median. Yeah, Antonio?
So does your median, when you have the 2 averages, is that like new numbers median? Does that add to like the entire numbers?
It doesn't add to your total of numbers, but it is the median, and none of your numbers are the median then, even if they're the same number. So if you're averaging, then the median is technically between them. Even if it's 16 and 16 that you're averaging, then they still don't count as the median. The median is still this line between the 2 of them. Then find the median of the data values below Q2. That's going to be your Q1. Find the medians of the values above Q2. That's going to be your Q3. So here's an example. I have these 6 numbers here. My median is the average of 2. It's between them. So it's 16.5. It's not either one of these numbers. It's the number between 16 and 17. So 16 is not my median, 17 is not my median, the number between them is my median. So then I'm going to find the numbers below my median. So it's going to be these 3. I'm going to find the median of the half below it. I'll find the median of the half above it. The median of the half below it is my Q1. So I'll look at that half here and say, okay, here's my lower half. What's my median? Oh, smack dab in the middle. That's my Q1. And here's my Q2. And then I take the upper half. There's my median of that half. That's my Q3. And again, even if these numbers are the same number, like even if it was 16 and 16, you would still not use either one of them because you're going to find the number between 16 and 16, which would be 16. Everybody are at that part? Okay. Or if that gives you trouble, then again you can just do what I did before, which is you split your data perfectly in half first. Find your Q1, find your Q3, and then find the median. If that, if you have trouble with doing it that way. The 5-number summary again is your minimum, your Q1, your Q2, your Q3, and your max. So here you can see 5-number summary. Even though so take your data, put it in order. If it's not in order, you're going to get garbage. Then these two, the Q2 is going to be the number between them. It's not going to include them. Find your lower half, the median of that, average of those two. That's going to be your Q1. Average of these two, that'll be your Q3. And then, of course, the minimum and the maximum. So we've done a couple of these already. Right? Again, if you put them in order, perfectly in order, then here there is. So this kind, I only have one number in the middle. So that is my median. I cannot split my data perfectly in half because where would he go? He can't be on that side, it'd be lopsided. He can't go on that side, so we ignore it. And we split our data perfectly in half, ignoring him to that side and that side. And we find our median of the lower half. That's our Q1. And find the median of the upper half. Sorry, my upper half and my lower half. Our Q1 and our Q3. Everybody, and then again, don't forget our min and our max. Okay. So we'll take a look and see what you folks came up with. So, did I really give it to you in order?
Yeah.
All right, so on the exam, I'm not going to give it to you in order, just as a heads up. So make sure that you are comfortable or used to the fact that you need to put them in order first. Okay. So here, we have one number smack dab in the middle. We have a lower half. We have an upper half. So my Q1 would be the average of these two, which would be 33. That's my Q3. This is my Q2. The average of these two, 62, is my Q3. Oh, sorry, this is my Q1. So sorry. All right, and then we have our min. We have our max. Okay, so there is my 5-number summary. 2, 33, 38, 62, 70. Good so far? Great. Then we have box plots. That's where you put a box through the Q1 and Q3, and then a line straight down, boxing in also the Q2, and then you have little line whiskers out to the min and the max. The important thing about the box plot is it should match up with your data. So from looking at the picture of the box plot, you should be able to see whether it's all scrunched up over here, and then there's a big old outlier over here, or you should see whether they're about symmetrical or not. You should be able to see how the data, if it's skewed or not skewed, from looking at the picture. So do not just draw. So don't just draw this and then put your values in wherever they go. Have this be 0, have this be 200, 201, 203, and 207. That's totally wrong because you're saying this distance is the same as that distance, and it's not. It's 100 times bigger, right? So this is trouble. Don't just do that. Right? Okay. The best way to do this is to kind of set up a number line. That's my suggestion. And as long as your number line is about evenly spaced, you don't even have to put everything. I would say, what's our numbers again? 33, 38, 62. Okay, I need to go from 0 to 70. So I'd probably just do this. 0, 10, 20, 30. And I was making these about spaced out about right. 40, 50, 60, 70, 20, 40, 60. You have to label all of them. Just label every other one. That's fine. All right. So then where do they go? 2, 33, 38, 62, 70. And then you're going to draw a box through these folks here, through the middle through Q2, and then little lines out to the end. Right? So you can see that, oh, there's a big old outlier over here, and these guys are really close together. And this is kind of long, and then this is also sort of short. Right? So you can kind of see from the picture how it should look. Yes?
Is it okay if the box is like on the number line?
Yes, that's fine. Put a box on them. The trick is, on the exam, will I be able to see the box? And I guess that's the critical thing. So if you're going to put it right on the number line, that's okay, but just make sure that I can see your whiskers that go out and that they're not, lost in the number line. Okay, outliers. Again, remember those are values that lie very far away from the mean, or from the vast majority of other values. And it can really affect the mean and standard deviation. The definition of one is any value that's less than Q1 minus 1.5 IQRs or greater than Q3 plus 1.5 IQRs is considered an outlier. What you need to know is, what does IQR stand for? What does letters stand for, IQR?
Interquartile range.
Interquartile range, great. And then how do we find our interquartile range? Q3 minus Q1. Interquartile So you do need to know, those are things you need to know for the exam. These things that I just filled in. I might ask you at some point, find the IQR of the previous, everyone do a second, find the IQR of the problem you guys just did in the quiz. Find your IQR. Take 15 seconds, find it, get out your calculators. Those of you not using a calculator, I'll probably call on.
Can you go back to that last page so I can just write it down?
Yes. It's in your notes though. Okay, Maddie W.
29.
How'd you find it?
Q3 minus Q1.
Q3 minus Q1. So 62 minus 33. And you got 29.
Yeah.
Good. Great. Right, that's easy, right? That's an easy 2 points on the exam. Good? Okay. Perfect. All right, then we got into chapter 5. This is reviewing chapter 5. Discrete probability distribution consists of the values of a random variable can assume. Right? If I roll a dice, what could I get? 1, 2, 3, 4, 5, or 6. So what could you get? Right? What could your, think about what varies. The easy way to figure this out, because we had a little bit of trouble last class, is what varies in the problem. Let me rephrase that. What is the thing I'm trying to find in the problem that changes? And it's not the probability, right? Because the probability is is not the thing, right? So figure out what is it that changes, and then figure out what all those possible answers for that are. So with the grab bag problems, the thing that changed from person to person was the value of their grab bag, right? So their grab bag changed, and so what could you get? You could get a $2 bag, a $3 bag, a $5 bag, and so forth, and then you have the probabilities of each of those. The probabilities need to add up to 1 or 100%, and every value needs to be between 0 and 1. So if you get a probability of 6, that's impossible. 600%? What you've forgotten is your out of. Do not forget the out of. This is going to come up a fair amount in these things. People say, oh, there's 6 of them. 6 out of, right? Because the probability can never be 600%. the expectation was the other main thing we talked about. So expectation, which is a big capital E, expectation of x, in other words, the expected value of x, is the same thing as the mean. Always. This is not just in this case. Always. The expected value and the mean are the same thing always. How do you find it? Well, how do you find the mean? It's a weighted mean. You take every x value, multiply by its weight, or its probability, and add them up. We don't need to worry about dividing by the sum of the weights, because what's the sum of all the probabilities always going to be? 1, or 100%, right? So I think you need to put this in your notes. Under the third page of your chapter 5 notes, where it says, it starts off with to do via calculator, and then the next part down is the expected value, right? Or expectation. Make sure you have this filled into your, towards the top of your third page of chapter 5 notes. All right. And I did a concrete example for you folks last time, right? I have 3. Yep, go ahead.
Can I have a copy of those notes?
Yes, they're against the wall. So if you're ever not here in class, against the wall is all the stuff we did last class, all those handouts. And we'll take a pause here. Okay, so continuing on. Remember, do it quietly, folks. Last class I said if I have a box, and in the box, thank you for asking that. If I have a box and in there is a number 1, a number 2, and number 3, and I draw over and over and over again, hundreds and thousands of times, on average, what am I going? If I average all those numbers, what would I get? So, and we said, well, sometimes you draw 2, so that averages to 2. Every time you draw 1, you'll draw a 3, and those average to 2 as well. So the average will be, the mean will be 2. This is it mathematically. A third of the time you'll draw 1, so 1 times 1/3. Third times you'll draw 2, so 1/3 times 2 is 2/3. Third time you'll draw 3, so 3 times a third is 1. If you add all those up, you get an expected value of 2. So that's how you find your mean, also known as your expected value. Henry, do you have a comment?
Oh yeah, I just wanted to say, could you go back so we could write that down?
You can take a picture of it quickly. So quiz problem 3. So next time you folks come in, if you miss class, you'll go right over there and grab that, right? Before class starts, before you're working on your quizzes. Or at the very least, you'll ask me like other people did, and they grabbed them. Okay. So quiz problem 3. Find the expected value of x. Does anybody need just 2 minutes to finish this up, or does everyone have this now? 2 minutes? Okay, 2 minutes, finish it up. At home, finish it up. Pause this until you finish it up. All right, so I need to multiply every x by its probability. So 0 times anything is just 0. 1 times 0.382, 2 times 0.6367, 34?
No, 0.73.
Yeah. And then 3 times 0.118 is 354?
Yeah.
Great. And then I add them up. So I'll get 0, 1, 7, 1, 4, 1.47. So my expected value is 1.47. Good. Now what's my mean? 1.47 exactly. So once you find one of them, on your exam, I'll ask for both of them. Just do the work for one of them. You do have to show me the work, right? You have to show me this part I did over to the right. Right, just those numbers, and then you added them. Right, that's all good. But once you do it once, the second part, just write down the number again. I'm asking you to prove to me that you know that they're the same thing. Right, so once you find one of them, just write down the same answer for the second one. Yeah?
Why are they considered two separate things then if they're the same?
Because
Is there like any cases in when they would?
because sometimes you don't have an expected value. So, you know, sometimes there's just a mean. So here, now we have something called the expected value. The expected value is the mean.
Okay.
Yeah.
Great, thanks.
Is it unusual for a family of 3 children to consist of 3 girls? What's our guideline for unusual? 5% or less? So what's the probability of getting 3 girls? 0.118? Is that unusual?
Yes. Or
Point-
no.
0.118?
12%.
Right, so this is 11.8%. Right, so what you do is you find the penny spot. The penny spot is the second spot, so that's 11, so that means it's 11 cents, and then just add whatever comes after that. So it's 11% plus a little extra, 11.8%. That is not unusual. It's not 5% or less. So that'd be no. 11.8% is more than 5%. Okay. Good. Next. Aha. So next, I'm going to show everybody how to find the standard deviation with your calculator. So the mean, what we just did, the mean, the expected value, you have to do that by hand like you just did, right? Where you do blank times blank plus blank times blank, right? Use your calculator, compute all those, and add them up. You cannot use lists. But for the standard deviation, I'm going to allow you to use lists. So let me show you how to do this. This is our example. Get the example up there. So here, everyone bust out your calculator or turn it on. Don't forget to turn it on in the bottom left corner. If you don't have it up yet from your computer, it's the web at emu. So it looks like this little rabbit right here, this little guy right there. So click on that, or just type in at the bottom, type in web at emu, W-A-B-B, and it comes right up. Open. All right, so here it is. Everybody have your calculator? Yes?
Yes.
Go to stat, right now, the stat button's right here in the middle. Don't forget to turn it on in the bottom left. Stat. You want edit, so hit enter. Down here at the bottom. Now you'll have lists. You might have stuff in the list. So if you have stuff in the list, arrow up so you're on the L2. Hit clear and enter, and it'll clear it. So arrow over so you're up so you're actually on the L1. Clear, enter. Everybody type in 0, 1, 2, 3, 4. And then under list 2, so your X's need to go in list 1. Your probabilities need to go in list 2. So list 2, type in all your probabilities. 0.18, 0.34, 0.23. Make sure they line up with their X. Right, because they're going to get multiplied across. So those should be 0. So arrow up. Click on the arrow up. 0. Enter. 1. 1. Enter. 2. Enter.
Yeah. Oh, actually, I don't know.
4. And then arrow over to the that part of it.
Let me go.
You can use it here. Point, whatever. Do it. Okay. Just let's go to list 2. You can use your keyboard. If you have a computer, you can use your keyboard, put numlocks on it, and use your keyboard if you want. And then arrow over to list 2. So use the one that I'm doing. Do my example.
Okay.
Don't do your one from your homework or from your your paper, do my example on the board. 0.18, 0.24, 0.23. All right, so get them all in there. Like I said, if you're on the computer, you can just type them in. 0.18, enter. 0.34, enter. 0.23, enter. 0.21, enter. 0.04. And then double check, make sure your data is all correct. Then we're going to go to stat, right here in the middle. And we're going to go to calc. So stat, and then arrow over to calc. Right arrow over to calc. I want 1 bar stats. 1 bar stats. Because we still only have one variable. We have one variable and the probabilities of that one variable. So it's still one variable. So 1 bar stats, hit enter, or hit 1 either way. And then I need to have, so most of you will have this calculator. We're going to put in L1, comma L2. If you have a fancy calculator, it may ask for list and frequency. If it asks you for list and frequency, then put L1 in for list and frequency into list 2. Oh, sorry, list 2 in for frequency, my bad. But we're going to do L1, comma L2. L1 is this little number down here in the corner above 1. So I need to hit second, because my second is blue, and then hit 1, and you'll see it come in here, L1. The comma is above the 7. And then you'll see the L2 is this little thing in blue above the 2. So you need to hit the blue button, and hit 2, and then the L2 comes in. Then hit enter, and then boom, you got it. So you should have 1.59 as your mean, and 1.12 is your standard deviation.
So just make sure I'm doing this right. L1 goes on this,
Yep.
L2 goes on
Yep.
that.
Yep. So then, and if you have the fancy one, just L1 for list, L2 for frequency, and then hit
I don't know, I got the index there.
second.
Okay, yeah, me too, so I guess you're.
Yep. Comma. Comma's above the 7.
Comma, second, 2.
Yeah. Yeah. Help. Yep.
It's like underside.
And then you went L1, comma L2. Second 1, comma above the 7. Comma's above the 7. Okay. Go to calc. Calc. And where's that? Hit enter. And then second 1, comma second 2. Okay, so once you get this one down, you folks have your own problem number 5, 4 in your notes to do. You have on the lab problem 4 on the previous page to do lab problem 4. I think it's on the second page of your chapter 5 notes.